Hello students, welcome to SmartKidz Tutorials. In this video, we'll be looking to quickly summarize the chapter of probability in order for us to quickly revise and go for an exam. So probability, as we know, is when we look to measure the chance, or we see what are the chances of a particular thing happening, and in this the thing we call is an event. So for example, we usually commonly take the example of a coin being tossed. A coin, as we know, has got two faces, a head and tail. And if we are looking for a head to come, that becomes our event to measure or to find out what are its chances of coming if we toss the coin. So that is what probability is about, looking for the outcome, or looking for what are the chances of that particular outcome when in certain cases, whether it is rolling of a dice, or whether it is picking of a card, or even removing certain items from a box, or for that matter tossing a coin. So when we look for a particular event to happen, that becomes what we call as our favorable event. And when we look to measure, we look at how many other events are possible in total, which may not be our favorable event. So the formula that is given to measure a probability of any event, which is given as P of E equal to number of favorable outcomes, okay, of a particular event upon the total number of possible outcomes in that particular uh, experiment. Experiment in this case would be the activity that we are carrying out, whether it is rolling of a dice or picking of a card or tossing of a coin. Now, if you notice, the number of favorable outcomes we always put in the numerator, and the total number of possible outcomes we always put in the denominator. Probability of any event can never be less than 0 and cannot be more than 1. Why it can't be less than 0? Because if it becomes less than 0, then it will become negative, and we are looking for a positive outcome, something that is going to happen or not going to happen. What are its chances? So if it's not going to happen, then it will be 0. If it's going to happen, then it may be less than 1 but greater than 0. Why it can't be greater than 1? Because number of favorable outcomes that we have is always going to be the denominator, which the numerator in this case is always going to be less than the denominator, which actually measures the total number of possible outcomes. So this, we are looking for the total number of possible outcomes, and so it will add up everything possible. So the numerator can't be greater than the denominator. It can be equal to the denominator. Remember, a probability of any event will always lie between 0 and 1. It can be equal to 0 but not less than 0, that means cannot be negative. It can be equal to 1 but never greater than 1, which means it can't be 1.1, 1.01 even. Okay. Now, whenever we are sure or certain of an event happening, we say the probability of that particular event is 1. That's when the numerator and the denominator, if we apply this formula, will become the same. The numerator is the same and the denominator is also the same. So, but if you get it in fill in the blanks or in your MCQ questions, probability of an event that is sure to happen, then remember the probability is always 1. Similarly, if we know for sure that that an event is not going to happen, or it is impossible for that event to happen, then we say the probability of that event is equal to 0. Okay, so probability of an event surely happening is 1, and probability of an event not going to happen, impossible to happen, is 0. If we add up all the probabilities, whether probability of an event happening or probability of an event not happening, or for that matter different probabilities, for that matter, if we, let's say, in a box we have balls of 3 different colors, and we look to find out the probability when we pick a ball from that box, we look to find out the probability of what is the probability of getting each ball of a particular color. Then if we go to add up all of the probabilities, then we will get the total will always come equal to 1 and never greater than 1. Okay, because all of them will have the denominator as the total possible outcome, which will be common for all three of them. So in this case, we are given for events A, B, C, probability of A plus probability of B plus probability of C will be equal to 1, because in each of these cases the total outcomes possible will always be the same. The numerator will change based on the favorable outcome that we are looking for, but the total outcome will remain the same, which means in the end we will have to take the LCM for them, which will be common for all three of them. They will have a common denominator, and so you will be able to add their numerators, and when we add the numerators, the numerator will become equal to the denominator, which will come equal to 1 eventually. So remember, sum of probabilities of all events will always be equal to 1. Now we come to complementary events. Here we were discussing about event sure to happen, not an event that is impossible to happen. If we add up event that is surely going to happen and an event that is not going to happen, then the answer should always come equal to 1. So when we look at a complementary event, we are looking of a probability of an event not happening. So we say P of not E equal to 1 minus P of E. But if you look closely, this minus P of E, if we take it on the left hand side, the sign will change from negative to positive. And in doing so, we will get an equation which will say that P of E, or probability of a favorable event, plus probability of the event not happening, which is given by the bar on top of E, is equal to 1. Remember, this is known as a complementary event, something that is, we look for something that is not going to happen, or the opposite event. Probability of event not happening is equal to 1 minus probability of an event. So these are general concepts of probability when we look to solve probability. Now let's look at some of the examples that we commonly encounter while solving problems in the chapter of probability. And three main examples that we can always look forward to are the ones which deal with coins or cards or even dice. In case of coins, we know that a coin has got two faces, heads as well as tail. So when we toss a coin, if we look for a favorable outcome, let's say we are looking for, in this case, appearance of a head. So the probability of getting a head will always be 50%, because the other 50% would be getting a tail. And in terms of fractions, it would be 1 upon 2. It will always be 1 upon 2, because the total outcomes possible is 2, that is head as well as tail. But we are looking for a favorable outcome, and in this case our favorable outcome is head, which means there's only chance for one head to come in one toss. So it will be 1 upon 2, because our formula is what? Number of outcomes favorable to event, which is 1, upon the total number of possible outcomes for that particular experiment. Experiment is tossing a coin, and total outcomes is 2, because we can get head as well, or we can get tails. Moving on to cards, we know that in a pack or a deck of cards there are 52 cards in total. There are 4 different types of cards: hearts and diamonds, which are red in color, spades and clubs, which are black in color, and each of these types have 13 cards in total. Okay, there is no number 1, but rather in place of number 1 there is ace. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have something called as jack, queen and king. All these 3 cards, that is jack, queen and king, are known as face cards, because there is a face printed on that particular card. Remember, a joker is not a part of a pack of cards or a deck of cards. In that case, if you are asked for the probability of getting a joker in a pack of 52 cards, remember the answer should always be 0, because it is not part of the pack of cards. In this case, we are asked to find the probability of getting an ace. In a pack of cards, there will be 4 aces always, one of each type, that is one of hearts, one of diamonds, one of spades and one of clubs. So number of favorable outcomes is 4. Total number of outcomes is the total number of cards, which is 52. When we put it in our formula, we will get probability of the favorable event equal to 4 upon 52, which when we divide, we get 1 upon 13. In case of a dice, we have all played dice at some point of time, whether it is on our phones, on our computers, or even while playing Ludo or Snakes and Ladders on a board game. Now, if you look at the dice, there are 6 faces, and each of the face signifies or resembles one number. The number is actually denoted by a dot. So there is one dot or one dent, you can say. It refers to number 1. Then 2 dents will show you that it is it's 2, and so on. The maximum number of dents that are present on a face is 6. So there are 6 faces, and 6 will be the maximum number on a dice. Now here you are asked to roll 2 dice and asked what is the probability of getting 12 as a sum. So that probability will always be 1, because to get 12 you have to add 6 and 6 for each of these dice, and the maximum number possible on each dice is 6. So which means the probability of getting 12 as a sum when these 2 dice are rolled together is only 1, because that will only happen when on both the dice you get 6 each. So that makes a number of favorable outcomes is equal to 1. What about the total number of possible outcomes? In that case, 6 we know outcomes are possible from one particular dice, but when we look at a combination of 2 dice being rolled together, then we have to raise it to the power of 2, because we are having 2 dice rolled together. So these are different combinations that are possible. You can manually find out the different combinations that will be possible when you roll 2 dice together, but mathematically we put it raised to square. If there were 3 dice over here that were rolled together, it would be 6 raised to 3. So here it is 6 raised to 2, means 6 square, which is equal to 36. And this is outcomes which I am talking about. Why there are 36? You can actually make the combinations. When you get on first dice you get number 1, second dice you get number 1, that will be one event. Then in the second event it will be on the first dice you get number 1, but on the second dice you get number 2, and so on. If you continue, you should get a total of 36. So in this case, our probability of getting the number 12 would be 1 upon 36, as we see over here. So these were some of the examples that we frequently encounter. There are many more examples that you learn in probability, and I'm sure you would have gone through them, but in a nutshell, this is what the chapter of probability is about, and this should help you to quickly brush up on the basics of probability before you go to answer your paper. Okay, I hope you found the video helpful. If so, please like it and share it with your friends as well as classmates. If you have not subscribed so far, please subscribe to the channel and keep watching for more such videos. Thank you for watching.